when looking at our number system, just to get some sort of order or understanding of how it all fits together, we can say that the big family of numbers, and the majority, 99% of the numbers we work with, are what are called real numbers. Those real numbers can be split up. Let's just use a pen here so we can see what we're talking about. So we've got the real numbers, and that's the big family, if you like, of all numbers that we're talking about, the number line. They can be made up of the rationals and the irrational numbers. Now, the rational numbers are made up primarily of surds, but also non-terminating decimals that do not repeat. Examples of that are like we've already come across pi, we've come across the number e. So they're examples of irrational numbers, surds, square root of 2, cube root of 30, etc. So they're the irrationals. Now, the rational numbers are numbers that can be expressed as the ratio of two integers. So we've got numerator divided by the denominator. It can be positive or negative. So the numerator is an integer and the denominator is an integer. And we've got the integers as well as a subset, if you like, of those as well, which are can be negative, 0, or positive. Now, there is another group of numbers which we will call the complex numbers. And the complex numbers, we use the symbol C with a little line through it like that. And I'm just going to go very briefly. There's a huge school of knowledge around this that will become evident as we go through things a little bit later, but just for the time being, we'll just introduce what are complex numbers, sometimes called imaginary numbers. Just because they are imaginary doesn't mean to say they're not useful. They're useful in a lot of fields of mathematics, where we are, in engineering in particular, where we're looking at trying to model concepts in electricity. And it's just a way of modelling. They are useful in the fact that they are able to give the what happens if we have this scenario. We can use complex numbers to be able to model that and to gain answers. So let's have a look at the complex numbers. If we've got, say, the square root of 4, we know that that's equal to 2. Square root of 4 is 2. If we had the square root of negative 4, we needed to come up with what happens if we've got the square root of a negative number. Go back to what the square root means, and that means that that symbol there, that radical sign, says that whatever the answer to this is, when you square it, you've got to get that number there. So the answer to this is a number which, when multiplied by itself, is going to give us negative 4. Well, 2 times 2, we've already said, is 4. Negative 2 times negative 2 is also equal to 4. Negative 2 times positive 2 is equal to negative 4, but we're not multiplying the same thing by itself. So that's not going to work. So we have to come up with another way of coping with the square root of negative numbers. So the square root of negative 4, as we've seen with simplifying surds, can be expressed as the square root of 4 times the square root of negative 1. Just when we multiply those two together, we get negative 4. This is a square number, so that will be 2. Square root of 4 is 2. And then the square root of negative number, mathematicians gave the symbol I to. So I is equal to the square root of negative 1. I squared is equal to the square root of negative 1 times the square root of negative 1. And that is just equal to negative 1. And we can continue on with that. So square root of negative 5 is equal to the square root of 5 times square root of -1 is equal to root 5i. Okay, mathematics. We need to be able to do maths on the basic operations on complex numbers. So if we had, for instance, add and subtract, so we had 3i plus 4i, we simply just add the numbers together. 3 plus 4 is 7i. 10i minus 3i. Also, voila. 10 minus 3 is 7, 7i. If we had 10 minus 2i, that can't be simplified because there is no surd there. So we'll just say that that is exactly the same as what it is there. We can't go any further than that. So adding and subtracting surds, multiply and dividing. If we've got 4i times 3, between the 4 and the I is understood to be a times, so it's 4 times I times 3. We can group things together with multiplication, so we can go 4 times 3, and we get 12i. As a shortcut, just multiply the two numbers together and just put the I at the end. So it's like multiplication there. Dividing, so if we add 16i divided by 2i, once again, it's probably best to write that as a fraction. 16i over 2i means exactly the same. The i's will cancel and 2's will cancel. Multiply out the top, 8 over 1. We just say that is the number 8. If we go to 3, let's go 30 over 5i. Now when we have an I on the bottom, it's not normal to do that. It's 30 divided by 5i. It is best, when the I is on the bottom, is to multiply top and bottom by I. Now once again, that is not changing the value of 30 over 5i because we're just multiplying by the number 1. So 30 over 5i, by multiplying by I over I, we'll multiply it by 1, so not changing the value. But what that does do is go 30 times I is 30i, multiply out the top, and then multiply out the bottom, 5i times I. So I times I is -1. And so that is 30 over -30i over -5. We are dividing -5 into the 30. Don't forget there's a multiplier there. So we could write that as 30 over -5i. A positive divided by a negative is a negative. 5 into 30 goes 6i. So if the imaginary, and there's no imaginary on the top, if you've got imaginary on the bottom, we tend to multiply top and bottom by I over I. So multiply the top by I, the bottom by I, and that will allow us to express our answer with an I on the top, and we'll get a number like that. So complex numbers, that's about all we're going to do at this stage. You will come across them in later courses, but for the time being, we've had a good look at our number system, how it is all structured. 99% of all your work is going to be involved in the real numbers up here. We'll do for further study in complex numbers. We need to be able to add and subtract imaginary numbers and multiply and divide them as well.